Okay, everybody. So what we're going to learn today is our family of functions. I have my calculator ready. I'm doing second mem 712, just again to clear it out because we're going to do a lot of different things on it. And you have all this information. Okay. So, I went too far. All right, so you could give your do now a try. And again, pause the video to give the do now a try. It's asking you what buttons you're going to push. Actually, I'll just show this to you, and then to do 34 squared on your calculator, you're just going to do 34, and here is your squared button. Okay, and I can hit enter. This is just teaching you where all the buttons are on your calculator. Square root function on your calculator, second, and then you're making sure you hit this square root button here, which I guess it is the only one. And I'm going to put in 256. Okay. A 15 to the third power, that's when you're going to use your caret button. So I would do 15. Here's your caret button to the third power. Hit enter. This cubed root, right? That's supposed to be a little 3. That's in your math button. That's why I called this just a regular square root. The other square root features are inside this math button, where this is your cube root function. It's choice 4. So I can hit 4. And I'm going to get that cubed root, and then I'm going to type in 216. So the cube root of 216 is 6. And now the absolute value function, this is the most common one that gets forgotten. The best way to do it is you see this catalog button, which alphabetizes everything the calculator can do. It's written in blue, so you activate the word catalog with your second feature, 0, and absolute value because it's the first in the alphabet. So when I hit enter, it's going to give me my absolute value feature. So I'm going to put in -5, and the absolute value of -5 is 5, which we're not really going to use it for that purpose. We're going to use it for the purpose of graphing. Okay? All right. Next thing that we're going to do. So here we go. We're going to start to learn our family functions. So the first one you already know, it is the linear function family. You have your y is equal to 2x, which is the same as, y is equal to x, which is the same as f of x is equal to x. Those are the same thing. You're going to go to your calculator, you're going to hit y equals, and you're simply going to type in x. You can look at your graph, which is cool, but you're going to need your table, second table, to get your values, which again, I'm gonna delete this little box here so that we can see my graph, but you should be graphing it, and I'm going to pull the table of values that I just got over here. Now, remember, this is a line whose slope is 1/1 and whose y-intercept is 0. That's what, because that's equivalent to just y equals 1x plus 0 is going to be the same as y equals x. So you're going up 1/1, up 1/1, up 1/1, or you're simply plotting these coordinates, which since your graph goes from about -10 to +10, don't forget you can scroll through the table of values to see those graphs. So this is your y equals x function. And then the domain is -infinity to +infinity, exclusive. And your range is the same, -infinity to +infinity. That's your linear function. All right, pause the video if you need to catch up on the table of values or graphing. Next one. Okay, so this next one is called your quadratic function, also one you have done. Your quadratic function is simply y equals x squared. So on your worksheet, you probably need to fill in y equals x squared there. Same as f of x is equal to x squared. In your brain, you should know you're going to graph a parabola. I'm going to clear out my calculator, and I'm going to put x squared. I can hit graph. There's my parabola. This is called the parent graph. It's the most basic of your parabolas or your quadratics, right? If I want that table of values in order to graph it, remember you're looking for that rainbow. Because my calculator is already shifted up to -5, I already see the 114499. I can see my quadratic function. I could see the rainbow, so therefore I could graph it very easily, right? Just let me move this out of the way. This was the table of values that you got. And then again, when you go to graph this, I do have a bit of a stray dot that I think I just put there. I'm going to very carefully try to connect my dots. It doesn't always go over so well, but I'm going to connect my dots and I'm going to make it curvy. This is your basic quadratic function. So far, all I did with you was the linear and the quadratic. You know both of those already. So this is nothing new to you. This rainbow effect that's happening in your quadratic table of values is familiar to you. Your domain for this particular quadratic, it's going to go from negative infinity to positive infinity. So I'm going to put it around my parentheses. And your range is going from 0 up to infinity because of those arrows. But the lowest point on the graph is 0. I am including the 0, and I'm including it right here because there's the point 0, 0 included. So it's inclusive, and it's going up to infinity for my range. And that's your quadratic function, right? Linear, quadratic. So now we're going to start with the ones you haven't seen yet. So you should be following along in your packet. Here comes the next one. This is your square root function. So see the word square root. So you want to write square root of x. Okay? So same idea. Come to my calculator, clear. And I'm going to hit second. So see what I'm doing? Second square root. And I'm going to put my x inside. And now I'm going to hit graph. So now things get a little bit interesting, right? In order to plot that, I'm going to look at my table of values. So I'm going to go second table. And once I'm in second table, see these error. I wish I were in class to say, why do they always say error? I'm hoping some of you realize it's because you can't have negative numbers under the radical. So that's why these don't exist for the graph. So your square root function begins at the point 0, 0. So I'm going to scroll down. Now again, I'm going to plot the point 0, 0. I'm going to plot the point 1, 1. Then I'm going to plot the point 4, 2. And then I'm going to plot the point 9, 3. I'm not going to plot the decimals. That would be super duper annoying to have to do. So I'm going to move this. Hopefully you're, again, like make sure you're doing this and not just kind of, just make sure you're experiencing it. If you're just depending on me and you're watching it, it's not good. So over here, again, I'm going to go to my highlighter to tell you I'm plotting the point 0, 0, 1, 1, 4, 2, 9, 3. That's this point, 0, 0, 1, 1. Square root of 4 is 2. The square root of 9 is 3, which is cool because it's a square root function. This is a stray dot. I'll move that out of the way. Keep creating these stray dots. Then I'm going to connect these. I need my regular pen. And this is what your square root function looks like. We've seen this graph on your tests, but you haven't known that it's a square root function. All right, this table of values down here, I'm actually going to write that I plotted the point 0, 0. I plotted the point 1, 1. The square root of 4 is 2. The square root of 9 is 3. And the reason I keep saying that is the next point on this graph that I would has integer values or integer xy coordinates is going to be 16 because the square root of 16 is going to be 4. So if I scroll down, you should expect that at the 16, you're going to see your 4 if you start to pay attention to what you're actually doing, which is why I always say to you, stay smarter than your calculator. Okay. For the domain, I'm going to fill in my domain here. I'm going to pick a different color. I'll pick green. So your domain, if I move this, so my domain is going to be from 0 to infinity, right? And I am including the 0 because look, I'm using the 0 for an x value. So it is inclusive on the 0 and it goes out to infinity for your domain. And the same is happening for your range. You're on the line, so it's including the 0 for your y value, inclusive on the 0, and it's still going up and up and up because look, that 3 became 4, which if I had 25 here, it would become 5. So this line does keep going up and up and up. So it does go up to infinity for your range. right? I'll move this table of values out of the way so that you can see my domain and my range. All right, I hope that makes sense to you guys. All right, that's your square root function. You want to become familiar with what it looks like. All right, next one. This is so much fun, you guys. All right, next one is going to be your cubic family. So we're cubing something. So down here where it says cubic family, you're cubing. So it's going to be x cubed, okay? So on my calculator, y equals, sorry, sometimes it gives me a hard time. I could clear this out. I'm going to do x to the, there's my caret, third power. All right, and then again, I can hit graph. Whoa, looks fancy. And then I could go second table to get it. All right, now this one, the reason I'm going to scroll right now is these numbers are just way too high for me to graph. And I notice they're decreasing in my y, which is I do want my y values to get smaller, so they're going to fit on my graph. So I like 64, I like 27, 8, 1. All right, so now we're getting into numbers that I can actually graph on my coordinate grid. So the numbers I'm going to pull off my table because they're graphable is -2, -8. So I'm going to write here -2, -8. I love -1, -1. I love 0, 0. These are all integers and they fit on my graph. 1, 1. Sorry that this is coming down to the bottom. And 2, 8. And listen, I do love 327 and 464, but they're simply not going to fit on my grid. All right, so I'm going to remove this and I'm going to talk to you about something else, right? So here's that table of values. So I have it if I want to talk about it. Now, these 5 points, am I lying? 1, 2, 3, 4, 5. Which point did I miss? Oh, I did miss one. That I plot all these extra points and now I forgot one. So the point I have missing is the point -1, -1. So -1, -1. That goes right there. So these are the 5 points I plotted. Now be careful. When you go and connect these, I think this is wrong as well. I think this one needs to be moved over. Sorry guys, I try to do things ahead of time to not waste time of yours, and this is not working. So I'm gonna move this over. That was the point -2, -8. Right here, -2, -8. All right, so when I connect these, it's kind of easy to like just draw straight lines, but I'm gonna go back to the graph and keep in mind this curviness of the graph. So when I go to connect these dots, that's what I need to be aware of. So I'm gonna connect and it's gonna come up and it's gonna go through and it's gonna go up. And I'm gonna remember my arrows, right? And again, by plotting the points, you are telling whoever grades your Regents exam what your table of values told you, because you're gonna make sure that they can clearly see the 5 dots that you graphed, your domain, because this does appear to go out and out and out, and you can see it in the table of values, is -infinity to +infinity. And your range is doing the same. It's going bottom to top with those arrows. So it too is going -infinity to +infinity. All right, so if you're ever asked to graph this cubic function, x to the 3rd power, that's how you do it on your calculator. And this is what the graph should start to look like. And you want to start to recognize them by shape, okay? Okay, I remember that when I cube a number, it grows quickly. So that's the sharpness of this graph. All right. Let's go to the next one. So this is your cubed root function. That's the one where, ready? So watch me on my calculator. It's going to have the this little 3 there. So I'm going to clear this. That you're getting from the math button. So you're going to hit math, and there's your cube root function, choice 4. There's cube root, and I'm going to put my x inside. And again, if I hit graph, I'm getting a visual. It's kind of like more slanted. That's why I told you that other graph grew quickly. X to the 3rd is going to grow sharp, where cubic root of x is going to grow slower because I keep cube rooting some of my numbers. I'm going to look at my table of values. And this is where knowing your perfect squares would be so cool. But I don't know how many of you know your perfect squares. So you might, sorry, not your perfect squares, your perfect cubes. I know the cubed root of 0 is 0. That's because 0 cubed is 0. And I know that the cubic root of 1 is 1 because 1 cubed is 1. It's like a bunch of double talk. I know that 2 times 2 times 2 is 8. So if I scroll down, the cubic root of 8 should be 2, right? And I'm going to kind of write what I'm saying. The cubic root of 8 is 2, and that's because 2 cubed equals 8. So I knew to look for the 8. As a matter of fact, if I go the other way, I know that -8 is a nice point as well, which actually ends up being the points I'm going to graph on this grid. Okay, so again, I'm going to make this disappear. All right, I'm going to move this over. And this is my table of values, which again, you can see the ones that I find of importance. There is the -8, -2. I'm going to plot -1, -1, 0, 0, 1, 1, 8, 2. So you're being smart. Those are 1, 2, 3, 4, 5 important points to me. When I connect the dots, I look at my graph. It's that curviness that's going on, so you want to be aware of the curviness. I will put the posters on the board for you, so you'll have them as a visual, right? So I'm going to connect these dots as curvy as I can, right? And I'm going to put my arrows. And again, for this, my domain is still -infinity to +infinity, and we have to agree that this is going to go up and up and up. It's growing up slower than our cubic function, but it's definitely going to keep going up. The next cube root I know is 27. The cube root of 27 is 3. And that's because 3 times 3 is 9, times 3 is 27. So you can start to, that's that logic component that you throw in. So the range is growing both down and up. So my range is going from -infinity to +infinity as well. All right, and you could put these highlighted points in this table. Those are the points we graphed. Okay, all right. Let's see if there's one more. I can't remember which one I did. Absolute value function, my favorite. This one, I'm going to go to my calculator. I'm going to clear this out. Remember, this is the one kids forget. It's in that catalog button. So you're going to hit second catalog, absolute value, and I'm going to put an X in there. Right? I can look at my graph. It's going to be a V. That's because absolute values are always positives. And that's why it's all above. That's why it's a positive graph. It's above the x-axis. But I'm going to look at my table of values, second table. I'm going to scroll to just get like maybe -9, it would fit on my graph. And actually all of these would fit on my graph. It's a lot of points to plot. And so would 0, 0, 1, 1, 2, 2, 3, 3, right? Absolute value of -2 is 2. Absolute value of -3 is 3. Absolute value of 3 is 3. Absolute value of 4 is 4. So as you graph this, if you stay smarter than your calculator, you can use that information in order to graph it. I'll show you what I mean. Number one, you want to remember for your absolute value function, it's a V. So then as I graph these points, I know that the absolute value of 0 is 0. Then I know the absolute value of 1 is 1. Absolute value of 2 is 2. 3 is 3. 4 is 4. 5 is 5. Right? Sorry, this is not cooperating for me, but 5 is 5. So that would go there. 6 is 6. 7 is 7. The absolute value of -5 is -5. The absolute value of -6 is -6. So I hope you're getting the idea of that. That simplifies this concept when you understand what you're doing. Connect the dots and put your arrows. For this particular graph, your domain is going to include 0 because the absolute value of 0 is 0. So that is a point on the graph. So it includes 0 and it goes to infinity. I'm sorry, that's my range. Did you guys catch that? The power of technology. I get to swipe this down. So let's back up. My domain is going from -infinity to +infinity. So here's my -infinity to +infinity. And my range is at the 0, but it goes up to +infinity exclusive.
And again, that's the absolute value of x. And this is my table of values. There's a lot of points that you could graph. Usually a common question is, do I have to graph all of them? And the answer to that is yes. Make sure you're plotting all the points and your graph is going through those points. If you want to cheat and stop sooner, then just draw your arrow. Don't just draw a line, because you might miss the points that it must go through. Okay, let's see if there's one more. Your exponential function. Here we go. We're getting crazy with this one. So y equals, here, pay attention to this because the range and domain is going to be a little funky, right? So it's going to be 2 to the x power. So again, I'm going to clear this and I'm going to do that again in case you missed it. Ready? So clear. I'm going to put 2 as my base, my caret button, and my x is my exponent. That's why it's called an exponential function. This one is actually going to be exponential growth, okay? I'm going to look at the graph, and I say growth because it's growing up. Now, this is why I tell you to pay close attention to this. This right here looks like this graph is touching the x-axis, but it really isn't. There is no value of x that will ever allow this graph to touch the x-axis. Let me show you, hopefully somewhat quickly, what I mean, okay? I'm just going to kind of write on the side. Stuff you know, 2 to the 0th power is equal to 1. So therefore, when x is 0, y is going to end up being 1. 2 to the 1st power is 2, right? So when x is 1, y will be 2. When you do 2 squared, you're going to get 4. So when x is 2, you're going to get 4. Okay, stuff I'm not sure you remember. If I give you 2 to the negative 1, that's going to be equal to 1 over 2 to the positive 1, which is really just 1/2. It's 0.5, right? Because negative exponents we pull into the denominator to make them positive. So when x was negative 1, my y was 0.5. It was actually positive. Let's do another one. 2 to the negative 2 is the same as 1 over 2 to the positive 2, which is going to equal 1/4. So again, notice when x was negative 2, y was still a positive number. It's 1/4 or 0.25. Okay, so what's happening is it's getting closer and closer. That's showing this is getting closer and closer to 0. That's what these numbers are doing, but it's never actually going to hit 0. I can see that in my table. So as I go up, see, when x is negative 1, I got 0.5. When x was negative 2, I got 0.25, and then 0.125. They're actually just cutting these fractions in half the whole time. And I'm going to keep going backward, and they're just going to keep getting smaller and smaller. They have to go into scientific notation because the numbers are just too big to write. If you, which I don't recommend that you do, but if you keep going backward, eventually your calculator may say it equals 0. But that's why you stay smarter than your calculator. That's never going to happen. And that's important to understand with your domain, right? So again, these are more the points. I'm going to plot the points that fit. So I definitely plotted, all right, let me just take a moment to get this highlighter to show you what I did. I plotted the point 0, 1, right? There's 0, 1. I plotted 1, 2, 2, 4, 3, 8. That's these going up this way. For the rest that were coming this way, that was all of these guys. You have to be, here you go. Here's a point on your test you will lose, and you will lose it on your Regents as well. When you are graphing these points, they must not touch the x-axis because you never actually touch 0. So you have to be very careful. So I'm going to draw my line. All right, and I cut it short because I was getting too close for comfort. So now, I hope I can pull this off with this little mechanism I'm writing with. I'm going to draw my line, and it's going to go up. There's my arrow, and I'm going to draw my arrow. I'm not going to draw anymore because I'm afraid I'm going to touch this x-axis, and I'm not allowed, right? And not being allowed means your range, while it gets super duper close to 0, it's never allowed to include 0. But it does go to infinity. Again, remember, that's your range, bottom to top. This is what makes this function interesting. The domain is still negative infinity to positive infinity. I can plug in all, oops, that's an 8, guys. I don't know what just happened there. So negative infinity to positive infinity for your exponential functions. Okay? all interesting, okay? Very interesting. All right, I'm going to skip these two because they're time consuming. I don't want to over worry about it. But here's your parent functions. I want you to see this and associate it with an exponential function. I want you to see this, and that's your quadratic. You might say parabola, which it is the graph of a parabola, but is your quadratic function. Your V shapes are your absolute value, right? Absolute value. And then this one, easy peasy lemon squeezy, this is your linear function. All right, if I were asking you to graph, so again, y equals, clear this out, this second square root x. Now watch what needs to happen. This little arrow is telling me I'm under the radical. Do I want to come out? Which according to this, I do. So I'm going to hit this, and then I'm going to hit -1. And the cool thing is, all it did was shift the graph down. We'll talk more about that. In the meantime, I'm going to plot my points. Errors make sense to me because I can't take the square root of negative numbers. So I'm going to go down. I'm going to plot the point 0, -1. This is going to be harder for me. And for the sake of the video, I'm going to let you. So 0, -1, and then I'm going to plot 1, 0, and then I'm going to plot 4, 1. There's my 4, 1. And then I'm going to plot at that 9, but it's going to be 9, 2, because remember, we kind of shifted it down. So 4, 5, 6, 7, 8, 9, 2. And ignore that stray dot that just happened. Oops, those are attached. Okay, fine. So 9, 2. And you're going to graph, and it's your job to remember this only gets an arrow on one side. That makes your domain, right? I am including the point 0, 1. So the domain is including 0, and it's going to infinity for your domain, right? And those are your vertical slices, domain. And for your range is the horizontal, so it is including -1 to infinity. All right? All right, one last one I'm going to do for this video. Y equals, hit clear. It's the cubed root. That's in the math button. So choice 4 in the math button. I'm going to put x. Now notice I still have that arrow, but I'm not coming out of the square root because the -5 is underneath. And we're going to talk about what we notice happening, but there's your cubed root. It all shifted. This little turning point shifted over to the 5. We'll talk more. But I'm going to do second table, and I'm going to graph the points that I can, like 4, -1. So I'm going to go to 1, 2, 3, 4, -1. I'm also going to plot 5, 0. And then I'm going to plot, I should go this way. I'll teach you a little. So I'm going to point -3, -2. So 1, 2, 3, -2, which means for this one, I'm pretty sure, oh no, it's shifting. So I have to, sorry, I'm finding that equivalent point. And again, it's my job to know that this is a nice move. So 13, 3, which is actually off the graph. And I'm sorry, it's 13, 2. So the whole time I'm going to stay below that 2 as I graph this. So let's do it. I'm going to graph this point. It's coming here. It's coming up. I think I forgot to point the point 6, 1. So I'm going to go through 6, 1, and then I'm going to stay below, and I'm going to go. That point 6, 1 was here, and I forgot to graph it. Okay? Again, domain, -infinity to +infinity. And then your range is going to go -infinity to +infinity as well, because we know our cubic functions are going to keep going. All right? I just want to see if I'm missing any good questions that I want to include. And no, those are good questions, but you're going to jump to your delta math. All right, have a great day, you guys.